Every cow has to say this again.
Hello, Precal. You might have heard Evan in the background there stealing my lines, but that's neither here nor there. So yes, today we're doing the tangent function. We're going to graph the tangent function. And as you can see here, I've got the unit circle back up on the board. You don't really have to copy this down if you don't want to, but I didn't want to just state this with no reason. The tangent function has a different period than sine and cosine. Tangent has a period of pi. Kenley Lepresti. Pardon me. I'm gonna continue on as if that did not happen. I lost my train of thought. Oh right, yes. Sine and cosine have a period of 2 pi. Tangent has a period of pi. After pi radians, it repeats, and that's what I want to show here. So all of the numbers in the pink purple color are the tangent values associated with each angle. If we start at 0, we got 0, and we go all the way around the circle here, and I don't end up with a repeat until right here at pi radians. I get another 0. That, I think, is just the best way to see why tangent has a period of pi. And so that does affect the formula for the period. We'll write that down real quick. For tangent, the period will be simply p equals pi this time, divided by the absolute value of b. And again, that is because it doesn't repeat values until after pi radians. Okay. From here, the rest is about the same. We take our convenient values here. Notice I've only picked values of x that are going to give me nice, convenient y values like 0 and 1. But something unique here with the tangent function is I have these undefined slots this time. And the way that's going to correspond to on the graph is a nice, lovely asymptote. So let's see that in action over here. And I probably should have said this at the start, but it's a video. Pause it, rewind it, do as you need. Get these down in your notebook for sure. I'm going to start plotting them over here. Okay, so 0, 0 is nothing crazy. At pi over 4, we'll jump up to 1. Okay, now here's our first undefined bit right here. All I have to do is draw in a vertical asymptote. So the way we're going to do that, at pi over 2, I'm just going to hit them with a dotted line. Like so. And we'll do that anytime we have an undefined slot with the tangent function. Continuing on here, the rest are pretty normal. 3 pi over 4 will be at -1. Pi is back at 0. 5 pi over 4 jumps up to 1. Then I've got another vertical asymptote here at 3 pi over 2. Then a couple more here. 7 pi over 4 down at -1. And at 2 pi we're at 0. And I know this minus pi over 2 is not in my table. I just put it here because it'll look kind of funny if I don't. There is another vertical asymptote here. And now I connect all the dots. Now remember, important part about an asymptote is that the line never crosses it. So when you come to connect the lines here, this one's going to plunge down like that and approach that asymptote, but never touch it. And likewise the same going up. And my tangent functions are always very, very ugly. I definitely recommend checking it out in Desmos to see it look proper. But yes, I'll do my best here. On these other ones here, I'll do the same thing. Have this approach down towards this asymptote, and then go up towards this one. And same with the two hanging out over here. Like so. And yeah, that is the basic tangent function. And I will see y'all in the next example with all the bells and whistles attached, all the lovely transformations.
You teach really fast when nobody can stop you.
Okay guys, time for example 1. So before I jump into it here, And as you can see, I've worked through a little bit of it already. I need to mention this part here that I forgot. I meant to say it when I had the graph on the board, but that's okay. If you recall, the definition of amplitude involved the distance from the x-axis to the maximum value or the distance from the x-axis to the minimum value, okay? Now, because tangent goes down forever off to the left and up forever up towards the right, it never actually hits a maximum or minimum value and therefore has no amplitude, okay? So it's not super crazy. It's not going to affect how we graph these things really at all. But when I start putting sine, cosine, and tangent all in the same assignment, I can't let that get you. So yeah, just remember tangent technically has no amplitude. Okay, but now let's do example 1 here. State the amplitude, period, and phase shift, then graph the function. And this is the function in question, -1/4 times the tangent of 2x minus pi over 2, and then plus 1 on the outside. Okay, so like I just said, tangent has no amplitude by definition. It's blasting off to minus and positive infinity in both directions, no amplitude at all. Now with the period, remember that the tangent function has a different formula for the period. It repeats after pi radians. So that's why I've got a pi up top and not a 2 pi. And then my value of b here in the bottom, that is just my number in front of x here. Okay, now the phase shift, I've written it down here already, but in order to explain where I got that, oh, actually I've got the wrong digit here. I need to make sure I factor that 2 out first, because that will affect the phase shift. And if we do that, we're gonna get, let's see, the -1/4 in tangent stay. And now I'm gonna factor out the 2, because that is in front of the x. That'll leave me with just x here. And if you do the math off to the side, remember, factoring means to divide. If you take pi over 2 and divide it by 2, you could do keep, change, flip. Multiply across there and you'll get pi over 4. Then the plus 1 hanging out on the outside. Okay, that means then my phase shift is pi over 4 units, and I have a minus attached to it. That is going to send me to the right. So my phase shift is shift right by pi over 4. Okay, that is all the preliminary information. Now let's start applying the transformations. And this part is completely the same as sine and cosine. You need to do stretches and compressions first, then your vertical and horizontal shifts. Okay, so let's see here. I've got a -1/4 on the outside that's being multiplied, and I've got a 2 on the inside that's being multiplied. So we'll deal with those first. Numbers on the outside affect the y-coordinate, and numbers on the inside affect the x-coordinate. So the first things I'll do in our table is multiply the y-coordinate by -1/4. Remember, the numbers on the outside behave. I don't need to take a reciprocal or anything. So I'll fill that in right here. We'll do y times -1/4. And then on the inside here, we're going to multiply x, not by 2, but by 1/2. The inside is irritating. You've got to do the opposite of what's written, so to speak. So I'll multiply x by 1/2. And now I've actually got to do that calculation here. I might write this part too fast. In fact, I almost certainly will. Definitely pause the video if you need to. Okay, let's do the x's first. Let's see, we'll have a 0 here, pi over 8, pi over 4, 3 pi over 8, pi over 2, let's see, 5 pi over 8. What else we got? Let's see. I lost track. All right, 3 pi over 4, 7 pi over 8, and pi. Those are all your x coordinates. And then with the y, that's a much simpler process. I'll have 0, negative 1/4. Oh, I'm glad I remembered to make a note of this. Don't get tripped up by the undefined. Undefined stays undefined. It doesn't matter what you multiply it by, add to it, whatever. It'll say completely undefined. So I'll just fill that in here. Okay, then continuing on, we'll get a 1/4, 0, negative 1/4, another undefined value here, negative 1/4. Oh no, excuse me, that should be positive 1/4, my bad. And then down here, another 0. Okay, lovely. That takes care of all of my stretches and compressions. Now I move on to the shifts. All right, and like I said, numbers on the inside affect x, and you need to do the opposite of what's written. Numbers on the outside affect y. Okay, so I will take the 1 on the outside here, and we'll add that to the y coordinate. And then here on the inside, it says minus pi over 4. But that sends me to the right, and I need to add. So we'll do x plus pi over 4. All right, and I'll actually do y first this time, just because it's so much simpler, and I want to make sure we're all good on adding fractions like this. So we'll run through the y's real quick. If I add 1 to all of the y's, we'll end up with 1 3/4, undefined, 5/4, 1 3/4, another undefined, 5/4, and a 1. Okay? And now with adding the fraction, make sure you have some scrap piece of paper or something like that, so you can write all this down, avoid really small mistakes. So the first one's obviously really simple. 0 plus pi over 4 is just pi over 4. But then when you get to the pi over 8, the denominators are different. Just write it out, y'all. Just write it out. I'll do it down here. I'm not going to do literally every single one, but I'll at least do this one. Okay, so pi over 8 plus pi over 4. You need those denominators to match. So I would like my pi over 4 to have a denominator of 8. Multiplying by 2 will do just that. Gives me a 2 pi here. Now I add them, that gives me 3 pi over 8. Lovely. You continue in that fashion with all of them. That's why it's very useful to have some scrap sheet of paper. I'll leave that stack of notebook paper on my desk. Y'all are free to use that if you would like. All right, but now I'm just going to fill in the rest because I don't want to be here all day. So yeah, 3 pi over 8 here, pi over 2 here, 5 pi over 8, 3 pi over 4, 7 pi over 8, pi, 9 pi over 8, and 5 pi over 4. All right, all that's left to do now is graph it, and I will do that off to the left here. Okay, you set these up just the same. All right, and you fill in a value here depending on what your biggest value is over here. All of these values are smaller than 2 pi, so I will bound it by 2 pi. And now I just start chopping it in half. I know half of 2 pi is just pi. And then if we keep chopping in half, well, pi over 2 would fall right here. And 3 pi over 2 would fall here. And notice I gotta get all the way down to 8 here. So I divide in 2 again. That'll give you a pi over 4 here.
He's recording.
A 3 pi over 4 here. A 5 pi over 4 here. And a 7 pi over 4 here. And I maybe should have given myself a little more room, because I still do need to have some 8s in here. We'll do a couple more divisions. Let's see. In between pi over 4 and pi over 2 would be 3 pi over 8. Let's see. In between 3 pi over 4 and pi would be 7 pi over 8. And in between pi and 5 pi over 4 would be 9 pi over 8. The y values are much simpler. They might be fractions, but that's fine. The whole number is 1. We'll put 1 right here. Minus 1 down here. The fractions I'll just estimate. Okay, so pi over 4 should be up at 1. 3 pi over 8 should be 3/4, so maybe about here. I've got my first undefined value, so that's where my asymptote will be. Okay, at, let's see, 5 pi over 8, I should have 5/4. Oh, and yep, that falls right here. I completely forgot to tag that in earlier. That goes up to 5/4, yes. Let's say about there. Right now, 3 pi over 4, that is at 1. 7 pi over 8 is at 3/4, maybe about here. Then another vertical asymptote, right at pi. Then 2 more here. I think I'm barely going to beat the bell. 9 pi over 8 is up at 5/4. And at 5 pi over 4, that is at 1. Now we just do our best to connect the lines here. This will be going up and up and up, off that way. This will be going down this way. And the rest follow the same pattern. Something to that effect. Doesn't have to be beautiful, so as long as your table is correct and this looks roughly like this, full credit from me, y'all. And I will leave your assignment with the sub. I don't have it ready at the moment. I'm making a worksheet for you, but yeah, I will leave that with the sub. Work on it for the rest of class. Finish it for homework if you need to. Y'all have a good rest of your day.
Okay.